Assalamu alaikum. This will be a short discussion on Unit 5 of Grade 11 Physics, which is about work, energy and power. Look, the first thing we will discuss in this video will be a work. In this, you know that work has different meaning in different areas. In physics, in our subject, the term work is used to simply describe transfer of energy, from one object or system, that means a combination of objects, to another, or converting energy from one form to another. This means simply work is transferring energy from one object to another object, or from one form to another form, because you know that energy has different forms. There is energy in electrical form, there is energy in heat form, there is energy in mechanical form, there is energy in liquid form, in chemical form. So this energy will be converted from one form to another form. This transferring of energy from one form to another form is called a work in physics. That is the work, simply. So this work, if this is the case, we have 2 pointers. These pointers keep in mind. The first thing is an object with lots of work or lots of energy can do lots of work. If it is energy transfer, if a work is energy transfer, so if object with lots of energy, that means it can do lots of work. The second point is when object A transfers energy to object B, the energy of object A decreases because it transfers energy. Okay, while the energy of object A will be decreasing, the energy of object B will be what? Increasing. Because object A transfers energy into object B. That is called work done. Work done by object A on B. This is work done by object A on B. Look, there are different examples for this. Lifting of objects, throwing them. These all actions which contain force, lifting, pushing, pulling, flow of current as mentioned in the note. All this needs work. That means in these all processes there is a work done. So the system or object must have energy. So must have energy to be able to do work on other objects or systems by transferring some of their energy. So if an object does a work, that means if an object it did a work, we will say it did a work when it transfers its energy, part of its energy or all of its energy. So go to the important definition of work. It says when a force acts in or against, that means in or against the direction of the motion. In means in the same direction of the motion. Against means opposite direction of the motion. If force is applied to in, that means in the same direction of the object, that is the motion, or against opposite direction of the motion, work is done. This work has a formula, the famous formula, work is equal to force, which is magnitude of force here. F here is magnitude, keep in mind, and D is the distance, also the magnitude of the distance, times cosine of the angle theta. This angle is the angle between the force and the motion. The angle between the force and the motion. You know that this formula is simply what? A scalar product of two vectors, force and direction, or change in position. So this means that in order for a work to be done, an object must have its position changed. It should change its position by the amount D. While a force, look, this point is important, while a force F is acting on it such that there is some non-zero component of the force in the direction of the displacement. There should be non-zero component. There should be non-zero component in the direction of what? The force application. In the direction of the force application. That means if our force is applied, for example, upward, but the body is moving horizontally, either right side or left side, if we are applying a force upward, but our body is moving either sides of horizontal way, that force has no work on this motion because it has no non-zero component on these directions. We'll see with this an example. We'll see this with an example. The next page says note important points. Note important points. We have to note these important 3 points. 1. What is 1? If theta is greater than 90 degrees, we have said that theta is the angle between the force and the displacement component. If theta is greater than 90 degrees, then the component is parallel to the direction of the displacement. If theta is greater than 90 degrees, then the component is parallel to the direction of the displacement. But point in the opposite direction and the force is opposing the motion. Okay? But point in the opposite direction. The opposite direction. And the force is opposing the motion. The relative direction of the force and the displacement is also, then it is important. It is important, the relative direction. If the component of the force along the direction of the displacement is opposite, okay, if this is opposite, what will happen? Opposite in direction to the displacement, then the sign of the displacement vector and force vector will be different. So the work done will be what? Negative. In this case, work done will be what? Negative. Negative work done will be there. Why? The force and the displacement are in different directions. That means opposite direction. We have said in the definition, in the direction or against the direction. That means opposite to the direction, work will be done. So, as we have mentioned, work is simply a scalar product of two vectors, which are what? Force and displacement. Force and displacement. You know that from your previous knowledge, if we have two vectors, ax, ay, and b, a vector bx and by components, then the scalar product of these two vectors is a dot b. A dot b. Okay, correct this one. A dot b. Okay? A dot b, not cross. Okay? A dot b, which is equal to ax bx plus ay by, which is equal to magnitude of A times magnitude of B times the force. That means the cos theta, which is the angle between theta. So this cos theta, magnitude of F and D is, you have to correct this one, magnitude of A, which is magnitude of F, times magnitude of B, which is magnitude of D, and cosine of the angle theta between them. This is the correct way. Maybe there should be here, it needs correction, okay? It needs correction, the handout. The handout needs correction. It is magnitude of F, magnitude of D, cosine of theta. Magnitude of F, which is the force, magnitude of D, which is the displacement. Look the example. Look the example. A car is traveling along a straight horizontal road. A force of 500 Newton is applied to the car in the direction that is traveling. That means it is speeding up. which means there is acceleration. It is speeding up means there is acceleration. While it is speeding up covers a distance of 20 meters. While speeding up means we have said that there will be acceleration if there is resultant or net force. Resultant or net force. If there is acceleration, that means there is a force. So that force moves somebody direction or a distance, so there is a work done. Calculate the work done on the car. The work done on the car by this acceleration, by this speeding up. The first page says, try the question, after that look the answer. Try the question, and after that you can check your understanding. The answer or the solution is the next page. You can see we have three important steps. Okay? You have to follow these three important steps. The first one is you have to extract the given. Here we have three givens. One, the magnitude of the force, which is 500 Newton. Two, the distance moved, it is 20 meters in the same direction of the force applied. And third is the angle theta. How you know it is 0? The angle theta, it is 0. How you know? Because the applied force and the distance moved are in the same direction. If it was in opposite direction, students, you have to make theta should be what? 180 degree. So no need of unit conversion. Okay, in your physics problem solving, you have to see the units. If it needs, so your next step should be conversion of the units. That means making the units compatible. Otherwise, your answer will be wrong. For this case, there is no unit conversion required because the units are all in SI unit, Newton, meter, and degree. So the second step is writing the formula. So work is equal to force times distance times cosine of theta is the formula we know. The magnitude, the angle. So simply substitute in the third step your values. So work will be force times distance cosine of theta. Force is 500 Newton. D is 20 meter. Cosine of 0 degree is 1. So you have 10,000 joule of work done. You see, the work is positive. That means they have the same direction. There is important note. Remember that the answer must be positive as the applied force and the displacement are in the same direction. In this case, look, this is important concept. In this case, the car gains kinetic energy. Why kinetic energy? It is a motion. The car gets motion. We have said that it is speeding up or accelerating. So, by the concept, we have said work is done. That means it gets energy. The car gets energy from the engine. The car gets energy from the engine. That is the concept of work done. So, we will come back to the next example and the next other concepts. Okay? So, keep in touch and please don't stop working and practicing. Be with us. Thank you very much.